Here, we show the system in motion. The pan is already preheated, and a piece of steak is placed into the pan. In order to collect ground truth data for machine learning, we insert a thermocouple into the steak, particularly in the middle layers, in order to measure the internal temperature. In the interest of time, we have now sped up this remaining part of cooking. While the steak is cooking, you'll observe the following on the screen. The top left is the masked version of the RGB frame with only the steak. The top right is the zoomed in version of the thermal image. The bottom left is the raw RGB camera frame, and the bottom right is the raw thermal frame. On the right, you will also see a color bar, which ranges the highest temperature and lowest temperature seen on the thermal camera. And on the right side, you'll see the machine learning outputs, in particular, the temperature prediction and the classification prediction. And we'll see here that the steak is about medium, and we'll take it off the pan. And as you can see, the meat turns out medium. The machine learning model achieved an overall classification accuracy of 76.2% with a within one class accuracy of 91.5%. The model also achieved a mean average error of 9.65 degrees and a root mean squared error of 14.62 degrees. Relating this to the overall temperature range, which can go from 60 to 180 degrees Fahrenheit, we observe that the percent error from this average mean error is roughly 8%. We note that while the percent error is rather low, the distance between thresholds for doneness all vary by 10 degrees. Thus, this error is still rather significant. This of course means that there's a lot more improvement that we can make to our project, and the shortcomings of our project are elaborated on further in the report. We now leave off with one more recorded trial. Do note the mispredictions at the end when the meat is supposed to be medium. Thanks for viewing our project.